Yeah.
So good afternoon, everyone. As you all know, I'm Dr. Neelam Dayal from IIT DM Jabalpur, and we all are gathered here to in the inaugural event of Skill Development Program on Internet of Things and Applications, which is a initiative, which is an activity under Asia Connect project on empowering girls to reduce the gender gap in IT and ITS sectors in South Asia region. Training and e-content development program. So before I talk more about this, specifically about this SDP, I would like to request Professor Aparajita Ojha, who is the PI of this Asia Connect project. Under her efforts only, all these activities are going on. So I request her to please introduce us about the Asia Connect project.
Thank you, Dr. Neelam. And on behalf of IIT DM Jabalpur and on behalf of all the coordinators of this project from 4 countries, I welcome you all to this very important course, which is definitely going to help all the students registered in this course gain skills in one of the most important emerging areas named IoT. This project, when we were thinking about this project, the basic idea was that in South Asia region, these countries, India, Nepal, Bhutan, and Bangladesh have rich cultural history, and they have been coordinating with each other. One thing which is lacking is participation of women in science and technology for the development of this South Asia region. So when we were conceiving this project, we thought of interacting with Nepal, Bhutan, and Bangladesh professors. And we were so fortunate that Professor Gajendra Sharma from Kathmandu University, Professor Surendra Gautam, and Professor Binil Aryal from Tribhuvan University, Nepal, and then Professor Yunus Ali and Professor Alim Al Islam from Bangladesh University of Engineering and Technology, and Dr. Tulsi Gurung from Royal University of Bhutan, from other countries, from 3 other countries, important countries, also gave immediately their consent. So our team became a wonderful team with 5 women professors who were working in different areas, and 3 equally important people, in fact 4 equally important people. One, Dr. Gaurav Trivedi from IIT Guwahati, and I have in this team Professor Preeti Khanna, who is an expert in image processing and computer vision and AI. And we have Dr. Neelam Dayal, who is a co-coordinator of this program, Dr. Kusum Bharti, also from my institute, who is co-coordinator of this program. So with this wonderful team of 9 people, we have been working together to basically help undergraduate students and teachers gain capacity in emerging IT areas. So Dr. Neelam Dayal is an expert in this area, and I'm sure that under her leadership, all of you are going to gain wonderful experience of learning through this online mode. I'm so sincerely thankful to all the center coordinators from 7, 8 different centers. And I welcome you all. Because of your efforts only, we could make it this way. Thank you so very much, all of you. Thanks, Neelam, and over to you.
Thank you, ma'am. So before we go ahead and interact with other dignitaries present over here, so I sincerely welcome all the dignitaries, the co-PIs and PI of Asia Connect project, our head of the department of IIT DM Jabalpur, Dr. Vinod Kumar Jain, the center coordinators of different physical centers all over the country and in Bangladesh and Nepal. So all of you welcome to this skill development program. So before I go ahead and interact with others, let me give a brief introduction about this program. So this Asia Connect project is under this project, we are running this skill development program on Internet of Things and Applications. We are partnering with so under this skill development program, these are the physical centers. So these are the physical centers that are from 7 centers are from India: Maharshi University of Information Technology, Lucknow; Sikkim Manipal Institute of Technology, Sikkim; GLA University, Mathura; Indore Institute of Science and Technology, Indore; Anna University, Chennai; Bangladesh University of Engineering and Technology from Bangladesh; Kathmandu University from Nepal; JP Institute of Information Technology, Noida; and Devi Ahilya Vishwavidyalaya, Indore. So these are the 9 physical centers from which, in collaboration with them, we are running this skill development program. So our aim was to connect all the centers through a single channel to provide knowledge to all the students. The IoT, which is one of the emerging trends in the current day. So to enhance the skills of undergraduate and postgraduate students in this domain. So the mandate of the SDP is to enhance the skills of undergraduate and postgraduate students and help them learn about the fundamentals of Internet of Things, design methodology, access technologies, hardware, networks, and different application domains of Internet of Things. If I talk about the technical details of this program, so we have, as I've already mentioned, we have made 9 physical centers. 7 of them are from India, and 1 is from Nepal, and 1 is from Bangladesh. We under this program, we have registered 1,011 candidates, out of which 70% are female candidates and 20% are male candidates. We are running these programs for 12 days, 2 hours per day, and we will be having 12 sessions daily for 2 hours. We will be having these sessions, and for these sessions, we have different resource persons from industry and academia. If I talk about the outline of the course, so we will start with Introduction to Internet of Things and Applications. That will be taken today itself by Professor Alim Al-Islam. The next topic, which is Basics of Wireless Sensor Networks and Networking and Transport Layers for IoT. These sessions will be taken by Professor Hari Prabhat Gupta from IIT BHU. We will be having Professor VK Gupta from IIT BM Jabalpur to introduce about IoT hardwares and different embedded devices, sensors, actuators, and other components. Along with him, he will be assisted by Mr. Mayur Mungule. If I talk about physical and data link layers of IoT, so introduction about this concept will be given by Dr. Munish Singh from IIT DM Jabalpur. Then we will be talking about application layer, cloud and data storage for IoT, and also data analytics for IoT. So the concept, these concepts will be clarified by Dr. Amrit Pal from VIT Chennai. Then we will be having Dr. Mayank Agrawal to discuss about security issues in IoT network, and also how machine learning can be integrated with Internet of Things. So these concepts will be taken ahead by Dr. Mayank Agrawal from IIT Patna. Along with this, we will be having several hands-on sessions also, where we will be taking help of Node MCU. board to understand how a IoT application can be created. So for that purpose, we will be having Mr. Jitesh Kumar, which is an industry personnel, to take upon the hands-on session in this course. If I talk about the registrations that are with different universities, so we have got 147 registrations for Anna University, which is a physical center for this SDP. 241 registrations are with Indore Institute of Science and Technology. 215 registrations have been made for Devi Ahilya Vishwavidyalaya Indore. 117 with GLA, 109 with Sikkim Manipal Institute of Technology, and 149 with Maharshi University of Technology. And there are several other students as well who are taking these courses from remote method through online mode itself. So this was all about our program, and we will be running our courses from 2:30 to 4:30 every day, and students will be joining the sessions in physical mode from their respective centers, and we will be taking the sessions of different industry and academia persons in online mode. So with this, I'll end the introduction to the program. So now I would like to request Dr. Vinod Kumar Jain, Head of CSE Department of IIIT DM Jabalpur, to please say a few words. Hello, am I audible?
Yes, madam, you are audible.
Yeah.
Thank you, madam. And first of all, I would like to congratulate all the coordinators and PI and co-PI of this project for organizing this wonderful event. And what I learned today, that this project is basically going to empower our girl students in science and technology area. So it's a very wonderful initiative that Madam Oja and Madam Khanna and all the team has taken. And I think that IoT is one of the important area in computer science and engineering domain, and not only in computer science and domain, in industry also, the fourth evolution of industry, that is IIoT, industrial Internet of Things. So that is very important for the economy of any country, especially in South Asia. All industries are lagging behind this important initiative of industries. We are not fully utilizing all the power of IoT in our industry. So honestly, if we are skilling, we are giving good skills to our undergraduate students, then definitely they will help the industries to work in this direction, and they will obviously take this take the advantage of IoT there. So with this word, I again thanks and congratulate all the team members for organizing this event. And I hope that all the participants will enjoy these 12 registrations, and they will learn good skills through lectures and hands-on. So all the best for all the students who have registered in this course. So, and again, I want to congratulate all the PIs and co-PIs. And thank you very much for giving me this opportunity to interact with so many people in South Asia region. So thank you, madam. Over to you, madam.
Thank you, sir. Thank you for your support. I would like to now invite Professor Gajendra Sharma from Kathmandu University, Nepal, who happens to be a co-PI of Asia Connect project as well. And he's monitoring the physical center in Nepal. Professor Gajendra Sharma, over to you.
Thank you, Dr. Neelam. First of all, congratulations to the entire team for organizing this event. So I think this is the third session or third time the program is going to be conducted. Usually nowadays IoT is very popular technologies. So because in IT we have emerging technologies like cloud computing, big data, AI, machine learning, and so many technologies. Among them, IoT is very popular. And there is a huge opportunity to conduct research in IoT so that our students can learn some theoretical aspects, practical aspects, and research strength in this area. So I think Asia Connect project is doing very well to aware, especially for female students in many technological issues, focusing on IT and computer science. This is really a great opportunity to learn new things from different locations, especially virtually, and apply them in practical purpose. And I am sure that those knowledge and these technologies can be very beneficial to change our society and to make our country better. And finally, I'm very happy to join this inaugural session, and I wish for the success of the entire session. Thank you very much, Dr. Neelam. Over to you.
Thank you, sir. In the sequence, I would like to request Professor Alim Al Islam to kindly say a few words. Hello. I think Professor Alim Al Islam is not here. So I request the center coordinator of Devi Ahilya Vishwavidyalaya to kindly say a few words.
Madam, good afternoon. In fact, I'm so delighted to see you. Thank you so very much for a kind support, ma'am.
Hello. Ma'am, your voice, you are muted actually.
Thank you so much, madam, to see you all again. Very nice to see you again on the same platform. So first of all, I would like to congratulate the entire team of ASI Connect for providing the facility, the opportunity for the girl students, young minds basically, to take up the transformational projects. And this is the era where it is really very, very apt topic. So again, I would like to thank you for such a important and highly useful technology to take up for the young minds. And I hope that all of our girl students, and I have seen that 30% male students are also involved. In fact, we were not sure that you are going to involve the male students also. Rather, we stopped so many students, male students. So if you allow us, we can allow them to sit at least in a corner or so, madam. So it is up to you, whatever you suggest. Because so many male students were also interested to, attend this. So anyway, it is up to you. If you allow, we can let them sit here in this hall. Because we are having large capacity here for the students to attend. So again, once again, I would like to thank you all for giving us the opportunity for our students to attend a very, very important topic in this era. Thank you so much.
Thank you, Professor Maya Ingle, and definitely we can allow male students as well to sit and take advantage of this course. So definitely they can also join the sessions. But of course, as the aim of the project is to empower the girl student. So that's why we have emphasized on the enrollment of girl student only at the beginning. But when the education we believe in free education. So of course, anyone can be allowed to take advantage of these sessions. So thank you, ma'am. And now I would like to request Center Coordinator of GLA University, Dr. Ajitesh, are you there? Hello. I think we can move ahead. Center Coordinator of IIST Indore, Dr. Rajesh Jain. Sir, are you there? Yeah, I think Dr. Ajitesh Kumar has joined. So, would you like to share a few words with us? Hello. Okay, so Dr. Vaishnavi is center coordinator for our physical center at Anna University, Chennai. Dr. Vaishnavi?
Yes, good afternoon
Good
to
afternoon, ma'am.
everyone.
Good afternoon.
Thank you very much, Prajita ma'am and Neelam ma'am. We are very much delighted to have been in this session for IoT and its applications. Last time we have done Python programming. It is very useful for girl students, and some of the boy students also, they are joining. It is very, very useful for us. Thank you for the Center in Asia Connect for giving this opportunity for us. Thank you so much, ma'am.
Thank you, ma'am. So I would like center coordinator of Sikkim Manipal University, Dr.
Yes.
Krishna Vijay.
Thank you, ma'am. Thank you for giving this opportunity. We are hosting this in collaboration with your, and we'll be looking forward to host the similar kind of activities in the near future. Thank you, everyone.
Thank you, sir. Center coordinator of Maharshi University of Information Technology, Lucknow, Dr. Rakesh Yadav.
Yes. Good afternoon, all of you.
Good afternoon, sir.
First of all, I would like to thank to the coordinator and organizer of this event. I think that IoT is a very emerging trend, and our students are participating here, and this must be very beneficial for our students. And at last, I would like to thanks to for giving me this type of opportunities to making the center for this as a Maharshi University of Information Technology, Lucknow, making this center. So I would like to thank for this. Thank you.
Thank you, sir. So I hope I'm not leaving any of the centers. Dr. Rajesh Jain from IIST Indore. Sir, are you there? I think we should move ahead. So before moving ahead, Professor Preeti Khanna. So before moving ahead, Professor Preeti Khanna, who is one of the co-PI of our project, ma'am, would you like to say a few words? Hello.
Is she available? She was available.
Yes.
Preeti Khanna ma'am. Maybe. What is SMIT, Neelam?
Sikkim Manipal Institute of Technology.
Okay, are they somebody is there who is co-hosting?
Yeah, yes, ma'am. It's Dr. Krishna Vijay Singh.
Let me call Preeti, and by that time you can.
Okay. So I think we have covered all the centers. So I would like to thank all the centers to.
Preeti is available. She was busy speaking with somebody. Yeah.
Yeah, I request Professor Preeti Khanna.
Yeah.
Preeti ma'am, are you there? Hello.
Yes, I am here only. Yeah. Now I am unmuted. Yeah. Thank you so much, Neelam, for this opportunity. And I will take this opportunity to congratulate all the participants here that they have got this excellent opportunity to learn new things from various experts over here. And this is giving you a platform. These courses, this project has provided a platform to all students, especially the girls students. And for that, I would like to thank our PI, Professor Ojha, for this initiative, and all co-PIs who are working to make it successful. And I'm also thankful to all the institutions who are joining us to make this program successful. And I extend my best wishes to Neelam and her team for the successful conduction of this program. Thank you.
Thank you, ma'am. So with this, I would like to conclude the inaugural event. So first of all, I would like to thank all of the people of Asia Connect project who were present over here for this inaugural session. Thank you, Professor Ojha, our team leader, Professor Preeti Khanna, Professor Gajendra Sharma, all the center coordinators, Dr. P. Vaishnavi, Dr. Neeraj Jain, Dr. Rakesh Jain, Dr. Maya Ingle, Dr. Ajitesh, Dr. Krishna Vijay Singh, and Dr. Rakesh Kumar Yadav for creating it possible to run the program on physical centers in their respective institutions. So without you, this program would not have been successful. So thank you for that. I would also like to thank all the students for showing so much interest in this program, so that we can run this with double energy. So thank you all of you to join us. And I guess Professor Alim Al Islam has also joined us, and we will be listening from him in few minutes where he will be taking the introductory lecture on introduction to Internet of Things. So with this, I thank all of the participants, the center coordinators, and entire team of Asia Connect project for your support. So thank you. So I request Professor Alim Al Islam. Sir, are you there?
Yes, ma'am.
Yeah. Sir, in how much time can we start your session? I wanted to know.
I'm ready, so anytime you would go, that's fine for me.
All right, sir. Then I think we can start the session right away.
Sure. Please.
Yes. So before you start the session, I would like to introduce Professor Alim Al Islam. Professor Alim Al Islam is associated with Department of Computer Science and Engineering, Bangladesh University of Engineering and Technology. He completed his bachelor's and master's from Bangladesh University of Engineering and Technology, Dhaka. After that, he completed his PhD from Purdue University, USA. Since 2007, he is associated with research and teaching. He has numerous publications, around 90+ publications in reputed journal and conferences. His main research interests are in wireless network, embedded system, Internet of Things, computer network security, reliability analysis, modeling, and simulation. As it happens to be, Professor Alim Al-Islam has been closely associated with our Asia Connect project as well. In different activities, he has enthusiastically participated. And in fact, we are coming up with e-content development for Internet of Things. In that particular e-content development activity also, Professor Alim Al-Islam is contributing. So thank you, sir. And with this, I will request Professor Alim Al-Islam to kindly take over from here. So.
Thank you so much. Thanks for the nice introduction, so generous. So I would like to share my screen. Is that enough? I'm not sure. Oh, okay. So in one machine, I can do that. From the other machine, probably there is something prohibiting. No problem. So I'm going with this machine.
Yeah, the screen is shared now. So.
Yeah, can you see my screen?
Yes, yes, of course.
Just a blank screen. Okay. So first of all, thank you so much for inviting me. It's an honor to me to have such a nice audience, such a mixed audience, people from different parts all over the world. So very nice to have this sort of attendance. Thank you so much. So just a brief introduction to me. I believe this is not that necessary after a so generous introduction by Professor Dayal. So who am I? I am from actually Bangladesh, and my graduations are from BUET, which resides at the core of the heart of capital of Bangladesh, that is Dhaka. And after doing my BSc and MSc, I went to North America, USA for my PhD degree from Purdue University. And then I again came back to my own institution, BUET, and since then I have been serving over here. So this is a just brief introduction to me from my professional and academic career. So today I would like to have some experience sharing with you. It's not like a talk. So it's just a brief introduction to Internet of Things and its applications. The later part will be more focused. In most of the cases, whatever I will try to share with you that comes from our own research group, that is Next Generation Computing, in short, NEC research group. So in this presentation, I would like to talk about the background on IoT, and in relation to that, I'll first talk about a little bit background about the industrial revolutions, because IoT nowadays that is completely linked with industrial revolutions. And I believe in the South Asian countries like India, Bangladesh, Pakistan, these sort of countries, in most of the times we are now hearing this buzzword, fourth industrial revolution. So I'll talk a bit about that, connect that with IoT, and then I'll talk about some basic technical perspectives of IoT. And in the whole presentations, the more focus will be on IoT applications, solutions for real cases, which will be mostly motivated by diversified example cases that have been done in our research group. So this is a brief outline. So let's start with a brief introduction on the basic thing, that is industrial revolution. So over the period of time now, we have been hearing that we are going to be in industry 4, that is 4IR. So if that is 4IR, that means we had 3IR, 2IR, and 1IR, that is industry 1, industry 2, and industry 3. So what were them? First, the industry 1, that was actually energized by steam, and most of the technologies invented at that period of time, around 1700s, those were actually energized by steam power. And after that, after around 100 years or so, the next industrial revolution took place, that is industry 2, and that was based on electricity. After that, the industry 3, that is mostly based on computing power. And now we are trying to get into industry 4, that is mostly based on connectedness. That is in our today's world that we aim for, we envision for to be over there. So in most of the cases, it is believed that countries like us, for example, Bangladesh, I hope in some parts of the India too, and similar other countries, it is generally believed that we are in industry 3 and we are thriving for getting into industry 4. So there is a fundamental shift over these industrial revolutions from 1 to 2 to 3 and 4. So when we go up, that is from 1 to 2 to 3 to 4, we can see two different parts of the technologies. One is the soft part and another is the hard part. So the more we are going towards the higher industrial revolution, the hardness is getting down and the softness of the technology is getting up. So this is a fundamental changes, a paradigm shift from industry 1 to industry 4. So in the case of industry 4, it is generally believed that there are 9 different pillars of this revolution. Those pillars are artificial intelligence, big data analysis, autonomous system, then IoT, cloud computing and cybersecurity, and also simulation, augmented reality and 3D printing. And among these 9 pillars, an important pillar is IoT. So you can see that over here. So if we see or if we claim something important, so that needs to be validated at least from 2 different perspectives. The first one is the service provider perspective, and the second one, that is probably even more important, that is the service recipient perspective. So let me show you recent statistics from these 2 different perspectives, that is service provider and service recipient. Here you can see that the left one, that statistics comes from the perspective of customers, and the right one that comes from the perspectives of hiring managers. So the service recipients lie in the left statistics and the service providers lie in the right statistics. And in both the cases, when they were asked about the importance or the significance of the recent technologies, you can see that among the top 3 in both the cases, there lies Internet of Things. So from the both perspectives, from the perspective of service providers and from the perspectives of service recipients, both of them actually think that Internet of Things, that technology is extremely important in today's world. Now, what does it actually mean by industrial IoT or Internet of Things? So if we want to understand the history of IoT, we need to check the evolution of IoT. So what do I mean by evolution? Just this figure, you can understand what do I mean by evolution. So it's the gradual change. So about the gradual change and the evolution of IoT, this figure can tell a lot of things. For example, at the very beginning, when the machines were not that smart, we had actually the pre-internet age, and most of the cases we had some sort of human-to-human communications. We had fixed mobile telephone, SMS, and so on. After the time when the networks actually got matured, then we got the Internet of Contents, that is www, and we got email, information, entertainment online. After that, when we got the IT platforms and services, smart one, then we got the Internet of Services, that is Web 2, and we got the e-productivity, e-commerce, and many electronic other aspects. After that, when we got the pervasive phones and applications, then we came into the age of Internet of People, and the revolutionary thought is that social media, for example, Facebook, YouTube, Twitter, Skype, a lot many. So after that arena, we got the devices and objects smarter, more smarter, and at that time, we actually entered the age of Internet of Things, and then we got the flavor of machine-to-machine interactions. And this is the kind of evolution from arena to arena, era to era, and from internet to Internet of Content, then Internet of Services, Internet of People, and now it is Internet of Things. So the focus of Internet of Things, that covers almost all parts of the world, and it is huge. How huge is this? You can see this figure. You can see the numbers. For example, billions of devices, trillions of dollars, and so many real life aspects that are covered by Internet of Things. So this is not only evolution, but also a revolution. So if we want to formally define IoT, that might look like this one, even though the formal definition could vary from one article to another article, but this is a kind of a basic definition, that is the Internet of Things, that is a kind of system that get interrelated computing devices, mechanical and digital machines, objects, animals, and people. And all of them, in general, have some sort of unique identifiers. They have the ability of transferring data over a network without requiring any human-to-human or human-to-computer interaction. So those are kind of having some sort of sensors, some sort of connectivity. then some sort of data processing, and showing that to the users. And these are the 4 critical or very important building blocks or components of IoT. And you can see them over here. The first one, that is the sensors or devices. Those actually sense the data. Those accumulate or capture data from our real environment or real life. And then using some sort of connectivity, they actually transmit the data. In many of the cases, they transmit the data to a base station, to a central server. And after that, when the accumulated data come to a central server, we need to do some sort of processing over the data to make them meaningful, to extract some meaningful information out of the data. And after that, the final part is to have some sort of very good user interface to show those data to the users in a clearly understandable manner. So this is the complete ecosystem of the IoT. And these sort of complete ecosystems of IoT actually have different types of real life usages. And this covers from our real life connected cars, our activity trackers. For example, suppose we are running or jogging, and that is being tracked by a device, and that is getting uploaded to a server. So even in case of some sort of parking stations, we have sensors, some smart parking areas. We do have some sort of health related sensors nowadays with us. And many parts of our city are now getting smarter with some sort of interventions of the IoT and so on. So these are some real life usages of IoT. As you can see that this cover a lot of parts of our real life. Those are also related to many other technical and research topics. For example, you can see over here, Internet of Things. Those are related to ubiquitous and pervasive computing. Those are related to internet protocol, communication technology, definitely with sensors or embedded devices. They have different types of applications. They are connected with people. And also some of the times they are not only Internet of Things, they do have some sort of intranet or extranet of things. So these are some other concepts or topics. Those are closely related to Internet of Things. So when I actually started my PhD study, I did some of the studies over this sort of connected topics. And at that time, during my PhD time, I was actually focusing on Internet protocol and communication technology. So what were those sort of research? So at that time, back to around 12 to 15 years, I tried to do some sort of innovations related to multi-radio communication. For example, in your pockets, I'm pretty sure almost every one of you do have smartphones in your pockets or in your bags. So nowadays we do have the smartphones, and the smartphones do have a number of radios within it. For example, Wi-Fi, GSM maybe, or Bluetooth, and many more. So if a device actually has many radios built in with it, how can we utilize those radios in an efficient manner? So that was the first topic that I explored during my PhD life. In the next case, in the wireless communication, for example, the way our smartphones actually communicate over the wireless medium, an important part is to understand how much time it is needing to communicate with other nodes or other stations. And this time is called round trip time. I'm pretty sure many of you actually know about RTT or round trip time. So this is like this: if one station actually initiates a transmission that goes to the destination, and an acknowledgement from the destination comes to the source, and the time difference between these two is actually the round trip time. And it is very difficult to have some sort of good estimation of round trip time, especially in the wireless arena. So my research was actually focusing on some sort of usage of smart machine learning technique. And here you can see that that was Q-learning, so that we can have a good estimation of RTT even in the case of wireless medium. The next one was about congestion control in wireless networks, having a number of nodes over there, like IoT cases. And here we actually used a kind of neural network. Nowadays it is very common, but back to 12 or 15 years, it was not that common, especially in this domain. So when I did this sort of research studies, I actually used different types of embedded device and also some simulation platforms, for example, NS2. And here you can see that the top one is the Beagle board, that is a kind of one small computer within the board, back to 12 or 15 years. Also a sensor node that is Telos B node. You can see at the bottom that was developed by University of California, Berkeley. So I was doing this sort of research, and some good publications were coming out at that time. So everything was very good. So just to my own personal story, at that time, when I came back to Bangladesh, many of my colleagues, many of my friends, many of my relatives actually asked me, why did you come back to Bangladesh? Because USA should be very fine. Why did you come over here? So when I try to answer this one, this is a real life question. This is nothing related to IoT, but I am sharing these things because this is related to our real life, especially in Bangladesh or in India. Many of the times we hear this sort of very common question: why did we come back over here, even after having some very good prospective careers outside, for example, in North America or Europe or Australia? So when I try to answer this question, I try to do that in a different way. For example, when I was in USA, I heard there are many problems in my own country, Bangladesh. For example, there are money problems, there are travel problems, a lot of traffic jam over here, there are health problems, there are family problems, and so on. I also heard another thing, that is, if you get back to Bangladesh, as I am a researcher, there is not enough provision of doing research over here. So when I heard these two different things, I actually got stuck, because when I started my PhD, the very first thing my professor taught me is that finding a research problem is around 80% work of a good research. So when I heard that there are a lot of problems in Bangladesh, I'm pretty sure that also is equally applicable in many parts of India too. And again, I heard that there is not enough provision of doing research over here. That becomes a kind of paradox to me. In another thing, in another way, so in case of doing a good research, we need to have some sort of good collaboration nowadays, because now modern day research needs collaboration. But after having this sort of advanced communication technologies right now in this world, collaboration is not a problem right now. So in our case, from our research group, we have collaborations with many other universities all over the world, in USA, in Australia, in the Middle East, and many other things. And also we are now collaborating with India, with you people, and Nepal, and many other countries, right? So it's always easy. So coming back to Bangladesh was not a very big deal for me, and it was nice to me, because after coming back over here, I could actually expand my research areas. For example, earlier, I actually focused on internet protocol and communication technology, but after coming back to Bangladesh, I expanded that to other research topics. For example, pervasive computing, then embedded device, and different types of applications focusing all types of people. So who are the all types of people? Let me show you. The very first thing, my own countrymen. Also, the similar thing happens for the other people with our neighboring countries like India. So these are the people from Bangladesh, India, Pakistan. The faces are pretty same. Not only that, the people from Africa, they are also covered with the problems that we actually deal with, definitely with the IoT types of solutions. Also, the first world country people, for example, the people from USA, we also try to do some sort of solution development for them too. These are some general people. We also deal with some sort of specialized peoples. For example, the blind ones, the visually impaired ones, they have some sort of special need, and we try to do some sort of solutions developed for the blind people or visually impaired people. Also, we have a different set in our society. Those are refugees, and you definitely know that we have refugees in Bangladesh who actually come over here from Myanmar. Those are the Rohingya population. We also try to do some sort of IoT related applications for them. Not only that, the bottommost part of the society, that is the extremely impoverished people, sometimes we call them beggars, we also try to do some sort of IoT related applications development for them too. These are kind of different types of people. We do have some sort of specialized applications or specialized real life scenarios. Maybe those are day-to-day experiences, or not day-to-day, but probably annual experience. So the day-to-day experience in Bangladesh that comes first to our mind is the traffic jam over here. So on-road experiences, we actually try to do some sort of IoT solutions development for this sort of problem over here in Bangladesh. And you can see this one, this is a kind of religious event, that is Hajj. that happens in Makkah every year, and that's a huge congregation. So we try to have some sort of IT related solution development for that too. And I'm pretty sure similar type of congregation happens in your country in India. If I'm not wrong, we do have a collaborator from South India in this international project in Hajj. And whatever I have learned, you have an event named Kumbh Mela, and that's also huge in India. So this sort of huge gathering, we try to do some sort of IT related solution development for this scenario too. So let's start with some of the solutions that we try to develop till now in our research, definitely based on IoT. The very first thing is related to our day-to-day experience, that is related to transportation. That's not related to road transportation, but railway transportation, that is often overlooked in case of developing new technological intervention. But whenever
Professor Islam, I guess your voice has broken.
Is he lost his connection?
Yeah, let me
Lost his connection, I don't know.
Professor Islam, hello.
Yeah, can you hear me? I have just
yeah.
got an electricity outage. Just give me a second. There was a glitch. So just give me a second, please. So
Yeah, now
back.
we can hear you.
Yeah. I have just connected from my mobile phone
Okay, fine.
of the electricity outage. Just give me a second, please.
Okay, sure.
Oh, sure.
And students, please feel free in asking questions through your center coordinators. You can ask questions.
Can you see my screen?
Yes, sir.
I'm extremely sorry. So there was an electricity glitch over here, and I just got out. So thank you so much for bearing with me. And definitely, at any time, if you would have any sort of question, just feel free to interrupt and ask your question, please. So what I was telling about some sort of IoT solutions related to different types of peoples, and I have already shown who are actually covered by those sort of peoples. And now let me show you some sort of real applications or solutions that are developed from our research group, definitely based on IoT. So the first one that we actually focused on is related to the transportation sectors, not the road one, but the railway one, because oftentimes we have found that is probably overlooked in case of developing technological intervention. And when I actually came back to Bangladesh, I saw that there are some sort of real accidents. Those were actually disastrous. So let me show you some events over here. It's not only from Bangladesh. You can see the top right one, that is from Bihar, India. So that is from your country. So these sort of derailments, that is not only prevalent in Bangladesh, but also in India, in many other countries, many other African countries. In the bottom left part, you can see that is from Congo. And the statistics from Bangladesh, you can see that in the right bottom part. So in case of derailments, the number is not that low. So we have found that around 92% of all the accidents over railway actually is related to the derailments events. And this sort of derailments, it's not anything surprising that they actually take the toll of many lives and also the property. So these sort of derailments, are they happening real time or not? So whatever we have found that in many cases, they actually happen real time. So the causes that comes into light just before a train runs.
That's why we need an automated and real-time system for early detection of this sort of mishappening. How can I do that? All over the world, you try to find this sort of solution, but probably you will not get that, because this sort of problem is mostly for the developing countries, not for the first world countries. And most of the developed research, those are happening in the developed countries, not in the developing countries. That's why probably you will find a very little research or very little related IoT-based solutions or any solutions for this sort of problem. So in our research group, we try to devise a solution for this sort of problem, definitely based on IoT. And in case of IoT, we have sensors in two different parts. The first one that lies in the rail track, and the another one that is actually placed or deployed in an incoming or approaching train. So the sensor that is actually deployed in the rail lines that senses the status or health of the rail line. So if there is any sort of problem with the fish plates or clips, the sensor actually senses that signal, and it transmits the signal to an approaching train, and the approaching train, that is the driver in the train, gets a kind of signal that it needs to be stopped because there is probably something not expected ahead of him. So in this sort of solution, we have two different parts from the very high level. The first part, that is the sensing part, and the second part, that is the communication part. And for the sensing part, you can see that these are some developed sensors, kind of definitely IoT solutions. We actually developed that from our research group, and we have deployed that in many real cases, and you can see some real case deployments over here. And at the beginning of our research, we actually tried to sense an approaching train from around 400 meters, but after some real field studies, we have understood that probably operation from around 400-meter distance might not that enough, because a human driver who actually drives the train might need some more time to stop a train when it is at the very high speed. So we try to extend that distance, the sensing distance, and later we have some specialized techniques with the IoT solutions and IoT developed boards, and we actually could sense the signal from around 1,000-meter distance, so that we can understand whether the rail line between the sensor and an approaching train that lies within around 1,000-meter distance, whether that is okay or not. So this is the sensing part. For the communication part, we need to have some sort of communications from the sensors that is with the rail line and the sensor that is in the approaching train. So there needs to be some sort of communications. And in case of communication, we actually try to use a cutting-edge technology that is called LoRa, using some sort of HML type of processing over the collected data. So this project was thankfully funded by the ICT division of Bangladesh, and a student from our research group who actually worked in this project. During the development of this project, he actually got a very good opportunity from Microsoft India, and Microsoft Research India, that is in Bangalore, if I'm not wrong. And he went over there, and now he is in Redmond, if I'm not wrong. So in many of the parts of this development, he had a very good contribution. So in this solution, we actually focused on some sort of sensitive infrastructure, that is the rail line. And in the next work, we focused on a bit more sensitive infrastructure. That's a kind of bank vault or armory where we need to have very restricted entries for the people who work over there. And for restricting the entries, for having a very good surveillance over there, the conventional method is image recognition and infrared detection. So these technologies are kind of matured right now, but the problem is that if we try to have these sort of technologies, we need to have some sort of cameras, because the cameras actually look over us, and vice versa. We also can see the cameras where they are. So there is a problem of getting exposed in this way. For example, when I can see the camera that is actually monitoring me, I can have a chance to destroy that too. So in this case of very sensitive infrastructure like bank vault or armory, the malicious users or the intruders should not have a chance to destroy the monitoring or surveillance device. So after having this sort of motivation, we try to understand what can we do so that we can have a surveillance or monitoring system in the room, in a bank vault, or in an armory, but an intruder can't understand that he is being tracked or he is under surveillance. So to do so, we actually thought that probably when a person enter a closed indoor setting, probably he or she makes some sort of changes in the environment, in the gases of the environment. For example, we built this sort of sensing device, and you can see that this sort of sensing device, we actually, with this device, we sensed carbon monoxide, carbon dioxide, nitrogen dioxide, sulfur dioxide, ozone, LPG, and with definitely temperature and humidity in real time with different number of people in a closed indoor setting, and try to relate that with the number of people actually present in that room. So when we try to do that after collecting the data, we need to have some sort of applications of machine learning. And it was our intuition that when we enter a room, stay over a room, probably our staying over the period of time probably have some sort of implications, temporal implications over the gases in the room. From that intuition, first, we actually employed some sort of sequential machine learning techniques, and you can see the performance of that sequential machine learning technique in the left bottom table. And these are the results in 3 different rooms with different sizes. But it was a surprising outcome to us that for sequential classifiers, the outcome was not that good. The accuracy was not that good. But when we actually deployed the non-sequential classifiers, that is, the classifiers, those actually do not depend on the temporal chronological events. For example, what happened in 1 minute back or 1 second back, that actually have some sort of implication of what is happening now. So these sort of classifiers, those are completely non-sequential. They have a great accuracy. For example, in case of one room, with a perfect accuracy, near perfect accuracy, like more than 99% cases, we can say that how many people are there in that room, just sensing the gases in that room. So this was a kind of very encouraging to us, and this was highly applicable for sensitive infrastructures. So in our study, after the sensing, after the sensitive infrastructures, we shift our focus to sensitive populations. And what are those sensitive populations? In our study, those are the visually impaired people. Why? Because from these statistics, you can see that all over the world, we have around 2.2 billion or even more visually impaired people. And the most pathetic part is that around 90% of those visually impaired people actually live in the low income countries. For example, in Bangladesh, definitely some parts of the Indias. So many of the visually impaired people are living over there. However, in case of these visually impaired people, when we try to build some sort of technologies, in most of the cases, those technologies are actually developed for the first world countries, not focusing on these 90% of the visually impaired people all over the world. For example, in case of educational technologies, you definitely know that in case of visually impaired people, they actually work with the palpable braille characters. And you can see that in case of a braille character, that would be 6 different dots, and different combinations of these 6 different dots actually give us different letters. For example, if we have these 4 dots, we can say that this is the letter T. So this sort of conventional braille printing, that is extremely expensive. How much expense they actually incur? Let me give you an example. For example, in case of a conventional braille printer, they actually cost from $1,500 US to $5,000 US. However, in case of our day-to-day life printer, that is around 1,500 Bangladeshi taka or Indian rupee to 5,000 Indian rupee or Bangladeshi taka. So you can understand the magnitude is like USD versus Indian rupee or USD versus Bangladeshi taka. So in many of the cases, braille printing per page costing is around 65 times of our normal day-to-day life printing. So that is extremely costly. So in Bangladeshi case, we have only one government press all over the Bangladesh for this sort of braille printing. So that is extremely costly. So in recent times, in many of the cases, we have found that in research studies, it is being told that probably braille that is getting replaced by our smartphones, because smartphones are now pervasive. So when the usage of smartphones is getting up, probably we can see that the usage of braille might decay, but that is not the fact. Why? a classical research study actually showed that if a visually impaired people, he is familiar with plain text, his employment rate is only 23%. However, if a visually impaired people is familiar with Braille and comfortable with Braille, the employment rate is more than double, that is 56%. Why is this happening? Because Braille is the natural language for visually impaired people. It is very easy to understand. It is very easy to use for the visually impaired people when it is Braille, not the plain text, like what smartphones does with the plain text. So Braille is a kind of unavoidable media for visually impaired people. So in our research group, we have tried to have two different IoT-based solutions for reading and writing with Braille. And you can see these are the two different solutions. One very simple type of thing, a kind of pen. And over there is a light source and a light sensor. And here you can see a kind of dice. Here we have actually six coupling of light source and sensing device, and the processing one is over here. It's a kind of wearable. So with these two different types of solutions, visually impaired people can easily read Braille characters from a book or anything else, where the Braille printing is not done by the Braille printers, but with our regular day-to-day life printers that I have talked that with 1,500 or 5,000 Indian rupee, you can just buy a day-to-day life using used printer. And with that, you can just print black dots, not the Braille embossed characters. You can just print the black dots, and those could be sensed by this sort of two different solutions. So for sensing that black dots, we need to utilize physics, and that is a very classical, simple high school physics. What is that? There's the reflection of light. So when we have a coupling, one light source that is LED and another light sensor that is phototransistor. And when the light source actually emit lights and that gets reflected from the surface of a page, very simple page, ordinary page, and that gets reflected and comes back to the phototransistor. The phototransistor senses, and this is the output value of phototransistor. You can see the red lines for the red part of the page. However, when the similar thing happens over a black part, the reflected portion is now very low in terms of the output that is captured by this sensor, that is phototransistor. So by exploiting this difference, that is the difference between the outputs actually sensed by the phototransistor, we can understand whether there is a black dot or not. So this is a very simple high school physics. So using this physics, we actually can print this sort of paper, definitely with a custom software that was built by us. The paper was actually got printed with a number of Braille characters, you can see over here. And you can assist visually impaired people with the two different types of solutions, one a pen-like solution, another a dice-like solution. And in both the cases, we have some acrylic board that is actually drilled to assist the visually impaired people to maneuver the pen or the dice. So the haptic sense is actually being given by this sort of acrylic board that is drilled to get maneuvered over the different trajectories to understand whether there is a Braille character or not. Now to understand the Braille characters, from the LED, we actually emit light, and after getting that reflected from the page, we get that sensed by the phototransistor. And then we actually check the output from a computational unit and try to detect the color, and based on the color, we get some sort of audio output to the visually impaired people, like a beep when we detect a dot, or in case of dice, we actually sense all the 6 dots all together and then understand what is the letter, and then tell the visually impaired people what letter is there under the dice. So this is the audio signal, and the visually impaired people, they can easily hear what is there over here under his pen or under his dice. And you can see that this is the visually impaired people who actually used our developed solutions. And this is just one case. We actually had several visually impaired people. Those are the visually impaired children from a school in Dhaka, and they actually use this sort of IoT-based solution. And the classical enhancement that we made through this sort of solution, this is a kind of paradigm shift that only with this dice sort of solution, from the very first time in the literature, we enabled the visually impaired people to write with the pen that we IT people actually use in our day-to-day life. And you can see that this is the paper. Here, different dots, those are written by the visually impaired people. They wrote this one and they could actually read this one with our assistive solutions. So this is not the one paradigm shift. Using this solution, we also had another paradigm shift, and that is related to the mathematics education for the visually impaired people. I'm pretty sure many of you probably know how the visually impaired people, they do the mathematics related work. How do they get learned about the mathematics? They use a frame called Taylor frame, and over the Taylor frame they have some different types of dice. They use those dice over there and do the mathematics. For example, for this sort of multiplication, they actually use this Taylor frame, and you can see these are the different digits. For example, 3, 5, then 1, 6, and using the classical conventions of multiplications, they do the next steps. And this digit presented mathematics of multiplication is done by the Taylor frame that is shown over here. So the very same thing we actually did with our developed solution, that is the dice-like solution, and here they can use the pen and the dice all together for writing and reading in parallel. And you can see that this math, that is the multiplication math, a visually impaired people did that over here using our dice-like solution that is actually named as flight, finger-guided light. So here you can see 35, then multiplication value and the value 16, and the rest of the multiplication is over here. The interesting part of this one, this solution was that the accuracy of doing mathematical exercises by the visually impaired people actually increased a lot with our solution. For example, in case of the classical case, the accuracy of addition and subtraction, that was around 35 to 37%. However, with our case, as that was very easy to use, the accuracy of doing the mathematics in case of addition and subtraction, that is near to 85 to 90%. The major advantage actually came from the case of multiplication. The case of multiplication, it is actually a nightmare for the visually impaired people. And you can see that the accuracy is less than 3% because it is extremely difficult to have this sort of multiplication done by the visually impaired children. But when our solution was given to them, that was so easy for them that the accuracy actually get around 75% to 80%. This is the advantage or the enhancement from the perspective of accuracy, and from the perspective of times needed. You can see that in case of our solution, as that was very intuitive to the visually impaired people, the time needed in the case of addition, subtraction, and multiplication, in all of the cases, the time needed is around 25% of what is actually needed for the classical case. So this solution was actually developed for the visually impaired people, a special type of people, but using the same high school physics, that is the reflection of light, we devised another IoT-based solution that was pervasive for all type of people. So what was the application? The application actually is shown over these different figures. Here you can see people from Bangladesh, also from India, they are using kiosk. And a common thing of using this sort of kiosk is that they are touching the device. So in all of the cases, touch is unavoidable, but there is a problem. What is the problem? The touch-based input device, they actually suffer from hygiene-related problem. And in the case of developing countries, as the population density is very high, the contamination that could happen using the touch in these devices, that is getting increased day by day. And we can readily understand what happened a couple of years back in our COVID period of time. So the touch that was not expected at all in many of the public places. And we do have some real life devices, for example, ATM keypad or elevator switch that are actually used by many of the people in the public places. So this sort of devices, for example, ATM keypad or elevator switch, that can get heavily contaminated, and the spreading could be very rapid because they are at the public place. So from this motivation, we try to devise a solution, again, that I have already mentioned, that is using the reflection of light. We try to develop the device that will not need any sort of touch. That is, it will be a touchless device. And you know, in Bangla, we called Sporshohin. when we talk about touchless. So we named this device as Sporshohin, and you can see that there are two different units. One, the coupling unit. Over here, we can move our hand close to this, apart from this, diagonal to do these, to have different type of gestures, and those gestures are recognized by this bottom computational unit. And this is the very small coupling unit. You can see that over here, the form factor is around 1.2 inch to 1.2 inch. So we can have very comfortable gestures in front of this sort of coupling unit. So what is the physics underneath? The very same one that I told earlier. So there is a light source and a phototransistor. Now these two are static. The part that is reflecting the light, that is our hand, that is now dynamic, that is moving. So when we move our part towards the coupling, the sensed reflected light, that is getting higher. And when we drag our hand far from this coupling, the extent of reflected sensed light, that is getting down. So this is the underlying physics. And using this underlying physics, we have different types of gestures using our hand towards or away from the coupling unit. The light get emitted from those gesture making hands, getting reflected and sensed by the phototransistor. From the real-time deviation in the sensed light from the phototransistor, we can understand different type of gestures over here. We can map them to different numbers or different outputs, and we can get that output signals to external devices. So what could be the different types of gestures? For example, we can have some straight gesture, hand is moving towards in front of the coupling. We can have some diagonal gestures affecting two adjacent coupling. We can also have some across gesture because the size of this sensing part is very small. So we can have some across gestures using our fingers. So over here, we can have a total of 10 different gestures, and at different lighting conditions, we have tested these gestures. For example, in daylight, like sunlight, under a tube light, in dark areas. In all of the cases, we had some very robust algorithms so that we can actually end up with around 99% accuracy. So after having this sort of solution, we try to make more fine-tuned solutions where the hand is not needed to be moved, but we can actually move our fingers, and with the fingers we can have different type of counts input to the device. So in that case, this is the coupling unit, looks like very similar, but now there are two different pairs, and now we can actually move our fingers in front of the coupling, and you can see that when we move the fingers, when the finger actually comes across the coupling unit, then the measured output voltage, that is getting high, and actually sensing this sort of higher sensed values, measured values from the phototransistor, we can understand how many fingers are drawn over there. So this is another type of solution that was developed from the very same physics, that is reflection of light. Those are very classical physics to us, and these sort of solutions are for all common people. And in the next case, for the common people, we developed another solution that is related to IoT security. So in that case, we try to focus on a smart IoT device that is nothing but our smartphone. And in case of smartphones, it is very needed to identify who is the user who is actually using the device. Why is that necessary? Because in current days, or in nowadays, we have many recording devices here and there around us. And using the recording devices, we can readily record what is being given in our smartphones as the passwords, or even as the different type of patterns. And in a research study, it was shown that in one side of the street, if a people is entering a password, here you can see in the right side, from the other side, over around 2 or 3 stories up, using a camera, the password can be captured, that is around 40 to 50 meters away. So this is now a reality. So in case of our smartphones, what we actually do for the user identification in general is that we have 3 different things. The first one is we have passwords of PIN, or we have some sort of hardware password like this one that we possess, or we have some sort of biometrics that is actually attached with us, for example, the fingerprint or iris. In case of the password or the hardware like of things is that they are lightweight, but they are very easy to attack, because if we can just see those, if we can just steal those, the security is gone. In the case of biometric, the stealing is probably a bit difficult, even though in recent times we can see that there are some research studies that can copy the fingerprints, even the iris. In case of biometric, the solutions are not cost efficient because they need some extra hardware. So in our case, we try to develop a data processing technique or a new mechanism that can be lightweight, difficult to attack, and also cost efficient. What is that? That is our usage biometric, how we actually use our smartphone. For example, in case of using our smartphone, I'm pretty sure that most of you hold the smartphone in a certain way, shake the smartphone in a certain way, tap the smartphone in a certain way. So how you are holding that, how you are touching that, from those, we can actually extract different features, 13 different features: the sweep positions, the sweep velocity, the finger pressure, hold time, and rotation metrics. So to get these 13 different features, we need to do only 2 different very simple operations. The first one is to sweep, and the second one is to tap. So from these 2 simple operations, we can extract 13 different features. And based on the dynamics in these 13 different features, we can actually understand who the user is currently using the smartphone. So when we test our solution, we actually tested that in different states of the user, for example, standing, sitting, walking, and jogging. And we understood that in case of moving status, for example, walking and jogging, the identification rate of the real user is not that good, because when we jogging, when you are doing some sort of jogging or walking, the holding and sweeping, that is not kind of fixed. But when we have standing or sitting states, at the static cases, we have some sort of very very normal usages by the users, very traditional usages by the users, very common usages. With those, we can understand who is the user right now. And you can see that in case of sitting and standing, the performance of identifying the real user is very good. Here is one side, but there is another side, that is, how can we understand that this solution can inhibit the wrong users, the malicious users? And that is the most interesting part of our study. So in case of inhibiting the malicious or other users, what we try to do, we have a very special experimentation with the malicious users. For example, user, that is user 1, who is the legitimate user, actually used the application, and another user, user 2, who observed that very carefully. Then we give the same device to user 2 and ask him to mimic. But he could not mimic any time. So the success rate is completely 0. Then we request the original user, that is user 1, to guide the user 2, so that user 2 can have some sort of good mimicking of user 1. And after this sort of training, when we ask the user 2, he could get a kind of success. For example, a maximum of 40% cases, he could have the success. But the interesting part was that after 2 hours, when we again invited user 2 to mimic the very same thing, he could not do anything. And from here, we can understand that memorizing this sort of usage of other users is extremely difficult. So this is very important for us. For example, in case of storing sensitive information like SSN or banking related information, these sort of techniques can be very handful. So in case of smartphones, we can have this sort of sensitive security solutions. Also, we do have some other recent sensitive technologies for communications, who are actually believe that they can communicate within a very short range of distance, and that's why those are extremely secure. For example, you can definitely hear about RFID.
I think we have lost the connection. Hello. I think there is some technical issue at the end of Professor Alim Al-Islam. So please bear with it. He'll be right back. So meanwhile, if students have any sort of queries, they can contact with their center coordinators to coordinate in asking these questions to the speakers.
So participants, we appreciate your patience. Please wait for a couple of minutes. So you can understand that South Asian regions have various difficulties, including the difficulties that we face quite often, right? Like power cut or internet disconnectivity. There can be many different issues with people living in South Asia region. So I think he has joined again, Professor Alim Al-Islam.
Yes, ma'am.
Have you joined? Yeah.
Yeah.
Who is this? Neelam?
Yes, ma'am. Ma'am,
Is it? Yeah, he has joined. Okay, fine.
Yeah,
Thank you.
So, ma'am, can you see me?
Yes, sir. Probably you have
Yes.
connected with cell phone, I think.
Yeah, the problem was that at the very beginning, I was actually connected with my office machine. Then after having the electricity glitch, I was connected with my own laptop and the internet is disconnected over there. And the last resort, that is my own mobile phone. I'm now connected with this one. So just give me a second to go over there. So this is the very last one I have with me. And if this is disconnected, so probably I am gone right now. This is the third one.
Okay.
So you can see my screen, right? So I'm just changing that.
Yes, sir. Yes, sir. Screen is visible.
Okay, just give me a second to go over there. So it is so unfortunate. So this is the very first time I had to go to my third resort. Yeah, so I talked about eavesdropping over here, and you can see that in the case of NFC or near field communication, even though it is commonly believed that the communication is within a very short range, but the eavesdropping can be done over there. And we have shown that using our laboratory setup. And for defending this eavesdropping, we actually built a jammer in the side of the eavesdropper so that the eavesdropping cannot be done. That is that in the rear side, we have some sort of jammer antenna so that the eavesdropper can't go over there. And this was done in some real setting with some real IoT devices. And in addition to eavesdropping, as the range of communication is very short, it was believed that probably even more sophisticated attacks, for example, man-in-the-middle attack, it is not possible for NFC, but in our laboratory experiments, we have shown that we can develop an attacker which can actually have some sort of reader, writer, and card. And in reality, with a very similar form factor, we can do the man-in-the-middle attack. And when you try to devise some sort of countermeasure of that, so in most of the cases, we believe that probably AI or machine learning will give solutions to every problem all over the world. But in this sort of problem, we actually failed. And you can see that with the machine learning techniques, we could not actually understand or identify the attacks even in 60% cases. That was less than 60%. So in these sort of cases, we had some sort of contextual information that could be leveraged to understand whether there is any attack or not. And that is that time of processing. So if there is an attacker, the time of processing actually gets substantially higher. So if we look over the processing time, we can have a remedy to this sort of man-in-the-middle attack. So even though the kind of machine learning is not enough or adequate over here, the kind of contextual information that actually helped. So this is a kind of solution for pervasive systems. Now I'll talk about solution of our pervasive scenarios. Actually, that is very common in case of Dhaka, and I'm pretty sure in many cities in India too. That is traffic congestion. And this is a kind of very common scenario over here. And I'm pretty sure when I am residing in Buet right now, delivering this speech, just near the road that is called Palashi or New Market area over here, those are highly congested. And you can see that in Dhaka, the public transport speed is 7 kilometers, which is getting around 4 kilometers by 2030, slower than the walking speed. The wastage is huge, $1 million of working hours and $1 billion of dollars. And it has been researched that 60% of those losses can be probably recovered using some sort of very useful technologies. For example, in the case of the junctions, if we could have some sort of optimization that could actually enhance the experience of the people over road. For example, if we could actually sense how many people, how many vehicles are over there, then analyze that with some sort of image-based deep learning approaches, and then send that to a central station, then it will be very useful for that. So this is the images that are captured, and those are sent to a central station, and the estimation of if traffic density is done. But the problem is that the network speed needs to be very high over here because the images are getting sent, but that is not a reality for developing countries like Bangladesh, India, and many other parts. So what is actually applicable to our context? We can capture the images there and also estimate the density on road. We should not send the images, rather we can just send the vehicle count to a central station, and the optimization can be done over there. But here, the new problem is that we are doing all of these things in embedded systems. Those are a very small system with very high resource constraint. So we need to do some sort of DL or deep learning or machine learning task with very high resource constraint. So the computational constraint that gives a new challenge to us. So over here, we actually did our research in our research group, and we actually perform the training task of machine learning in some sort of high-end device that is shown in the left one, the GeForce machine. But after the training, that is one shot, we deployed our trained module in a very small IoT device that is called Raspberry Pi. And we had our own developed solutions, own developed models that we termed with the name of the capital of Bangladesh, Dhaka, that is DhakaNet and DhakaNet Scaled. And you can see that, pardon me, please. You can see that in both of the cases, with respect to the classical alternatives, we can have highly accurate and faster solution for capturing and understanding the images on road. We had a small implementation, real life implementation in Dhaka. An industrial area in Dhaka is called Tejgaon, and you can see over there we actually deployed our solution in real time, and we captured the images. We then understand how many vehicles are there in the images and send that over cloud in a system that is hosted in Buet, and you can see that the number of vehicles in real time we can understand from our solution. So these are some sort of crowded vehicles in reality. We do also have some sort of crowded people populations in reality that is not in Bangladesh, that is in Makkah, that I told at the beginning. That is in the case of Hajj, we have a large crowd in Makkah, even though these crowds are shown during the COVID period of time, but these are not the reality. The reality is like this, a huge crowd over there. And as I told you, I'm sure there are some huge crowds in India too. And whatever I have heard, there is probably Kumbh Mela, that's a huge crowd in India too. So in this case of crowds, for example, in case of Hajj, we have a number of cameras deployed, already deployed over there, and those are some sort of IoT capturing devices, and those are capturing the images in real time, and using those images, we actually perform some sort of counting and localization using some data processing technique, again using the notion of deep learning. And you can see the outcomes of our research work, the data processing, and the red dots, those are actually put on the heads of the pilgrims over here, and those are done by the smart or intelligent data processing by a model developed by us. So these are some common people, but in case of our country, we do have some sort of other special people over here, like I have already talked about visually impaired people. Also in Bangladesh, we do have some sort of refugees. For example, in a couple of years back, we actually experienced an influx from Myanmar. And in case of these refugees, when they come over here, most of the cases, we are actually very worried about how can they get survived over there. And we are actually worried about supplying foods to them. But in our human being cases, we have two parts. One is body and another is mind. So when they are pushed from their own country to our country, definitely there are some big impacts over their mind. But there was a little amount of work about what is happening in their minds. So from our research group, we went over there and we worked with the Rohingya refugees, and we tried to understand what is their mental states using an IoT device called MindWave that actually reads the wave transmitted by our brain. This is the snapshot of that device, and using Bluetooth, we collected the brain signals, and these are some different brain signals like alpha, beta, theta, and delta. And we actually utilize these sort of signals to identify what is the mental status of those Rohingya refugees. And you can see in case of one signal that is called low beta, that is extremely correlated with different types of mental states and mental disorders, for example, post-traumatic stress disorder, insomnia, anxiety, stress, and so on. So this work, in this work, we extended it further, and we actually blended a kind of real freehand sketch. So we actually requested the refugees to have some sort of freehand sketching, and these are the freehand sketches. And from the freehand sketches that is shown in the right part, you can see that we can extract many different attributes or features, and blending those features with the brain waves that is collected by IoT sensing devices, we can actually identify what is the extent of PTSD among the Rohingya refugees with an accuracy of more than 99%. So that was a kind of interesting study to us, because we blended HCI with IoT in this research. And in the last case that I am going to show, going to share with you is kind of very similar population like refugees, and those are the extremely impoverished people. Oftentimes we call them beggars. So in case of Dhaka, in around 12 years back in 2011, we had 40,000 beggars, and after 5 years in 2016, we had 70,000 beggars. So in Dhaka, it's a huge population. So in case of healthcare, whatever we have found from our field studies that when a beggar gets sick, he or she actually goes to just a normal pharmacy for general sickness, and for emergency, they go to hospital. Both of them are very harmful to them. Why? Because when they go to the pharmacy, oftentimes, as they are not contacting the doctors, they get wrong medication. And when they go to hospital, in many of the cases, those are the last minutes of their life. So these are very alarming to us. So we had some sort of real field studies to understand whether there is any healthcare services available for them or not in Dhaka. And we visited a number of hospitals, and you can see the green ones. Those are completely affordable even for the beggars, but they don't know about the information that these sort of services are available for them. So we try to understand then how can we make a solution that make them aware that this sort of services are available to them. We try to understand whether they have some sort of mobile phones and whether we can get this information available to their mobile phones. So we had a survey on field. We surveyed 70 beggars. You can see that most of them do not have smartphones, and a few of them actually have feature phones. So those are not free working to us. And in general, that I have already told you, they go to pharmacy and takes the medicine from the just a layman people who are not actually doctors. And when we tell them whether if we can make the information available to them regarding the affordable healthcare services, will that be helpful to them? And you can see that 97% of them are saying that, yes, that will be extremely helpful. But then we need to understand what is the lowest part of the society who have smartphones and who are interacting with this sort of beggars. Then we understand that the shopkeepers actually have the smartphones, and the beggars, they actually interact with the shopkeepers. So we went to the shopkeepers and we try to understand what is the technological proficiency of them. And we have found that many of them, after interviewing around 70 shopkeepers, they have smartphone usages at a very good level. They have internet usages at a very good level. And from the philanthropic perspective, they have a very good intention to help the beggar with the information. Those are actually helpful for them. So based on this understanding, we actually devised a solution where there will be a web server, and the hospital personnel actually input what are the medical services those are affordable for the beggars. And when a beggar gets sick, he or she will go to a shop representative or shopkeepers, tell what he or she is feeling, and after that shopkeepers will input that in a IoT solution that is like a mobile app that was developed by us, and the shopkeeper will input those symptoms of the beggars in our mobile app. Then the mobile app will connect to the web server. Then from the web server, it will try to extract what are the affordable services nearby for the beggar, for the requesting beggar, get those suggestions, and then the shopkeeper will have a look over there, and they will inform the beggar where he or she can go for the affordable healthcare services. So in this solution, you can see two different parts are there. The bottommost part, that is the technological part, and the upper part, that is kind of social interaction part. So we termed this solution as a techno-social part. And we actually deployed that for over around 6 months period. And we actually observed that in many of the days, beggars come to the shopkeepers and they took these services for their real life applications, and it was really helpful for them. So this was the kind of end of my technological presentation. Just to wrap it up, as I began with Industry 4, I have just one more slide that is on the future. So we should always try to project on the future, and the future is not Industry 4 but the Industry 5. So what's the difference? So you can see this figure, and for the very first time in Industry 5, you can see this one is included. This is nothing but human. So in Industry 5, it will be very evident that the technologies will be personalized and the technologies will be philanthropy. So up to Industry 4, the human beings, we were mostly pursuant to technology. And nowadays, we have understood that only technology is not probably working, and we need to have human in the loop. And we have understood that is the importance of human being in recent COVID period. And in our cases, for example, in Bangladesh, and also very similar to the case of India, we have a lot of people over there that is not that prevalent even in the first world countries. So up to industry 4, probably the first one countries, they were leading. But in industry 5, as we have more people than them, we should have some more leads. We need to lead the next industrial revolution, that is industry 5. And we need to make it very clear that as we have many people over here in Bangladesh, in India, and people is the best asset all over the world, that is more than technology. So we should lead the world in near future. Thank you so much. And any question, that will be completely welcome to me.
Thank you, sir, for this wonderful insight in what actually Internet of Technology, Internet of Things is, and giving a brief overview about in what ways we can utilize the IoT technology to build up applications around us, right? So thank you so much for giving this insight. And now I welcome the questions from different candidates, the participants which are present on the physical centers. So I request the coordinators, center coordinators to kindly coordinate on it. If students are having any question, please pass those questions to us so that Professor Alim Al-Islam can address those questions. Yeah, I think IIST Indore, Dr. Rajesh Jain. Rakesh Johnson. Hello.
Yeah.
Dr. Rakesh Jain, is there any question? Because the center is unmuted. All right, sir. Meanwhile, centers are, collecting the questions. There is a question in chat box. So this is Devrat Tiwari from Maharshi University of Institute and Information and Technology, Lucknow. He is asking that how we can convert IoT into business and how to be implemented. So I think how it can be implemented has already been addressed by Professor Alim Al-Islam. So he will be repeating it, but his main question is, I think, how IoT solutions can be, brought into the business part.
Thank you. Excellent question. So probably I'm not the right person for answering the business related part because I am from the technology domain. But whatever I have understood from my brief experience is that whenever you need to make some sort of useful technology, the problem that needs to be very real. So whenever you take a problem that is worth solving and then you develop a solution, probably definitely you have a very good chance to make a business case. But for the business perspective, it's a completely different arena. So how you make your business model, what should be the cost structure, what should be the marketing approach, those are some different things. But the very first thing that is very common from business perspective, from technology perspective, is to have your problem a real one. If you have that problem that has some sort of very good business value in the long run, and you make the solution of that problem, probably you are in the very right track, and with some sort of business people intervention, you will go into a real business, I believe so. So this is the very first thing. In case of Bangladesh, also in India, in many of the cases, when we do our research, actually, when I also was a student in Bangladesh, in many of the cases, we try to pick a problem that is not probably real from our perspective. Sometimes it's a problem in North America. Sometimes it's a kind of fabricated problem for writing a paper. But if you want to do a business, please make sure that at the very first footstep, the problem is real and that is worth solving. So this is the very first thing. And the next parts, probably the business people who are experts will guide you better, I believe.
Thank you, sir, for addressing this question. Any other question? So students who have joined through online mode can write down their questions in the chat box as well.
Ma'am, I'm from DAV Center Indore, and my question is, what is the use of IoT in relation to cybersecurity? Am I audible?
Yeah, you are audible. Sir, have you got the question?
Yeah, can you please repeat that one?
Yeah, I think it's Anshika. Is that Anshika from DAVV?
Ma'am, I'm Umang, and I'm from Medicaps University, and currently I'm attending this seminar in DAV. My question
Okay.
is the use of IoT and cybersecurity.
Use
So
of IoT and cybersecurity, right?
IoT in cybersecurity domain, I think.
Yeah, so that's a classical blending right now, because in case of cybersecurity, the security is related to the cyberspace. There is not only the physical space, that's the domain, digital domain. So when you have IoT, that is actually getting blended with both the worlds, the physical world and the cyber world. So the part of IoT that is in the cyber world, that is you are collecting your data, you are communicating your data, then you are storing your data, then you are processing your data, then you are showing information extracted from your data. All of these are done in the cyber world. So in each of the cases, for example, in case of collecting the data, I have already shown you the security attacks like eavesdropping and man in the middle, that is related to collecting the data. When you actually transmit the data, in the case of transmission medium, there could have some sort of security threats, and definitely there are some countermeasures for overcoming this sort of security threats. In case of data processing, even there are some recent research studies that deal with how to fool the deep learning models. So in case of data processing, this sort of cybersecurity attacks, those are related to deep learning and many other data processing aspects, those come into play. And also while showing the data to the users, the visualization, then that can also be under cybersecurity attacks, because probably you are processing one data, but your user interface that is under attack and that is showing another data. So in each of the cases, in each of the phases, in the ecosystem of IoT, the cybersecurity is completely blended, from data accumulation, data collection, up to the user visualization. So could I answer your question?
Yes, sir. Thank you so much.
Thank you. Any other question? So there is a question in the chat. What are the enabling technology involved in this project? I think they want to ask what are the enabling technology involved in IoT, I guess. That might be their question. And which platform is used for data collection?
Okay, so enabling technologies. So enabling technologies that depend on your work. For example, from the data collection perspective that you have already asked to, from the data collecting perspective, we have a number of sensors available. For example, if you want to sense your environment, I have already shown you there are different types of gas sensors. If you try to understand the shaking of the earth surface, that is very relevant to recent times earthquakes, you can understand. So there are some sensors, dedicated sensors for that. So if you have some sort of autonomous vehicle types of applications, the motion sensors are working over there. So based on your applications that you are focusing, the sensors, the sensing devices will differ. And in case of accumulating those sort of data, you need to have some sort of computational devices, and I have already shown you Raspberry Pi or Arduino Uno or different types of microcontrollers. Those are actually in operation in those areas. And after getting the extraction of the data, when you try to process the data, you need to have some sort of high-end device. If you need to have some sort of deep learning enabling technologies over there, for example, probably you will need some sort of GPUs over there. So these are some hardware related platforms. I'm not sure whether you asked about the software or hardware related platforms, but I think these sort of hardware related platforms, these are the very first thing that we need to be completely familiar if we try to do some sort of work in the world of IoT. So does that answer your question?
So someone from IIST Indore, I think they are asking this question. One more thing I would like to add upon it, as Professor Islam correctly said that, it totally depends on at what particular layer, at what particular application level you are requiring. So there are multiple technologies involved, in IoT domain. And in fact, in the coming next 2 weeks, a couple of weeks, we are going to discuss one by one about them itself. We will be starting with the hardware layer, where Professor VK Gupta will be taking you to what are the different embedded devices, what are the different sensors, actuators for collecting the data. Then we will be going ahead with understanding the communication part, what are the different technologies involved at data link layer for connectivity, what are the different technologies used at networking layer and application level for the communication purpose, what are the different data collection, data processing technologies, cloud platform, application development platform. So, there are different lectures lined up for that, and probably your question will be well answered during different sessions at what different layer we are, how we are including different technologies to evolve the situation. So I think that will be much more clearer to you in the coming days. So any other questions? Yeah, Monty, is there any question from your side? Okay. I request all the center coordinators to kindly confirm that if there are no more questions, we can conclude the session then.
Yeah, Professor Doyle, that will be really great for me because I have another meeting just right now. So I believe if there is any more question, I'll be very happy to have that in the future. If they can just email me, just feel free to do that. So I have my email. I shown that at the very last slide of my presentation. So just feel free to email me anytime. So I'll try to get back to you.
Sure, sir. I'll share the mail ID with different center coordinators. They will communicate that mail ID with the students. And if any student is having any query, you can directly feel free to contact Professor Islam. He will be very much, happy to answer your queries. So with that, thank you so much, Professor Islam, for joining us in such a short period of time. So thank you, sir, for giving us insight in the IoT application domain.
Thanks to you all, and also my humble apology for all the mishaps during the electricity outage and internet outage. So please pardon me from my side, and thank you very much for inviting me. Bye.
Thank you, sir. So Dr. Rakesh Kumar Yadav, do you have any questions? Yeah, yes, sir.
No, only no question, no more question, madam.
Okay.
Thank you.
Thank you, sir. So with this, I would like to conclude the session. Before concluding the session, I would request all the center coordinators to kindly inform the candidates that the minimum requirements for obtaining the certificate in the course, we require 75% attendance of the candidates, as well as there will be 2 quizzes, first on 25th of February and second will be held on 3rd March. So aggregate of 40% marks is mandatory for obtaining the course certificate. So I want, with this, I want to, thank all the center coordinators and the participants to joining us. And tomorrow we will be having the session for wireless sensor network introduction. So basically, when we are talking about IoT from the technical, a generic overview of networking to how IoT comes into picture. So wireless sensor network basically creates that bridging between the traditional technology to IoT, right? So basic understanding of that domain is very much important. So that's why we have arranged this session of understanding the basics of wireless sensor network, which is very much important for undergraduate students specifically to understand the technical aspects of the communication technology in a better way, right? So this session will be taken by Professor Hari Prabhat Gupta from IIT BHU. So if you guys have any question, please ask. Otherwise, we can conclude the session.
Yes, okay. Thank you, ma'am. Thank you.
Thank you, Krishna Vijay, sir.
Thank you, ma'am. Thank you.
Thank you, Ajitesh, sir. Thank you, Vaishnavi, ma'am. Thank you, Maya Ingle, ma'am. Thank you, Rakesh Yadav, sir, Rakesh Jain, sir. So thank you, Professor Gajendra Sharma, Professor Alim Islam, and all the participants connected with us. Thank you so much for joining us. And tomorrow we will be starting the session at 2:30 sharp. And in between, if any sort of problems that are you people are facing for the communication purpose or broadcasting the sessions to the students, please let me know, so that tomorrow we will be having better solutions for those problems. Thank you. With this, I end the session. Thank you, sir. Thank you, everyone.